Hello, today I want to show you how to represent Pythagorean equations in a different form if we are given three positive integers such that a squared plus b squared equals c squared. Then we can represent a as m squared minus n squared, b as 2 times mn, and c as m squared plus n squared. There m and n must be positive integers. To prove this, at first notice that if all of these numbers are divisible by some number k, we can divide all of them by the k, and we will see that these divided numbers will also satisfy the equation. So we can assume that GCD of a, b, and c must be 1. And we will see that GCD of a and b must be also 1. Otherwise, c will be divisible by this number. At first notice that at least one of the numbers, either a or b, must be even. Otherwise, if both of these are odd numbers, a squared must be b squared and must be 1 mod p, 1 mod 4. So c squared must be 2 mod 4. And clearly this is impossible because we know that 2 is not a quadratic residue mod 4. So at least one of the numbers, b, must be either b or a must be even. And with all laws of generality, we can assume that b is even number. And look at b squared must be c squared minus a squared. And c and a are odd numbers, so this is c minus a times c plus a. Now, because we know that c and a are odd numbers, both of these brackets must be even number. So if we assign this as 2 times m and 2 times n, and b is 2 times t, we get that 4t squared equals 4 times mn. At first notice that GCD of c minus a and c plus a must be equal GCD of a 2 times a and c plus a. And clearly this is 2 because a and c are coprime numbers. And from here we can conclude that GCD of m and n equals 1. They must be coprime numbers because they are half of c minus a and c plus a. From here we can conclude that if we cancel out 4's, we get that t squared equals m times n. M and n are two coprime numbers, which means that both of these must be perfect squares. M equals x squared and n equals y squared for some positive integers x and y. And from here, how can we define c and a? C minus a equals 2 times x squared, and c plus a equals 2 times y squared. If we sum up these two equations, we get that 2 times c equals 2 times x squared plus y squared. So c must be x squared plus y squared. If we subtract these two equations, if we subtract second minus first, we get that 2 times a equals 2 times y squared minus 2 times x squared. So from here we can conclude that a equals y squared minus x squared. And we have already defined b, that b is 2 times yx. And clearly this is the form of the initial statement. And now we need to verify that all these numbers satisfy the Pythagorean equation. So now let's look at what will be b squared. B squared, it must be 4 times y squared x squared. What will be a squared? A squared must be y to the 4 minus 2 times y squared x squared plus x to the 4. And what will be c squared? It must be x to the 4 plus 2 times x squared times y squared plus y to the 4. And if we look at a squared plus b squared, this is y to the 4 plus 2 times y squared x squared plus x to the 4. And clearly this is y squared plus x squared squared. And this is clearly c squared. And this is what we wanted to show. This was all I want to discuss for today. If you want to discuss in other theorems, please write in the comments.